And we're live. Uh, just give it a couple minutes before so people will sign in before we get started. Good morning, everybody. We are going to be going through the lessons on the live streams today. If you are doing the lessons, or as you do the lessons, you can watch the videos from the past few days as I go through the lessons. It's largely going to be what I'm doing on this live stream. The live stream is mostly giving you an opportunity to ask questions. Uh, in your email, I have a live stream schedule for you to access. And you can also, in your email, there's a Discord server that you can ask questions on, or you can just text me like normal. Uh, you all have all of that information. And this is how class is going to go basically all day. I will put up a quiz every 2 hours, and then 15 minutes before I finish the quiz, or I start a new quiz, I will be uh, I will be starting a live stream that will take 15 to 30 minutes, depending on how long the quiz is. I will be posting a link to the live stream in the Discord, or you can subscribe to my YouTube to get a notification about the stream. The stream should be accessible just by going to my YouTube channel, and that should be it. All right, guys, so let's get this started. With a circular mill is a circle with a diameter of 1 mil. So, not circumference, diameter. Circumference is the measurement around, diameter is the measurement across. And we're going to do this in a few questions. Calculating circular mills from mils, you square the diameter in mils. You can get all of this information on your blended learning. In your code standards and practices lessons. We are going through these lesson by lesson. Lessons 2 and 3 are combined together into one quiz. You can see your references to get all your information. Then down here, understanding the principles involved with the sizing of building wire. This is where a lot of the information for this actual quiz came from, is all of this here. And it's a really short bit of information. And you can access that on your own as you go through this. Alright. Next up, a 6-gauge copper conductor is smaller than a 10-gauge copper conductor. That is false. You can, if you don't already know that, you can check in your code book. Chapter 9, Table 8 has all of the wire sizes listed. That's towards the back of the book. If you have tabs on your code book, there's a tab for it. But it's all listed there, and you can just look. It goes from small to large. Yeah, that's all there is to say about that. What is the maximum size conductor that is generally permitted to be a solid conductor where installed in a raceway? That is number 10. So this, if you look up conductors, then stranded under conductors in the index, it will take you to 310.106C. A lot of people have issues with this particular code section. It's the way it's worded. It says conductors sized 8 and larger must be stranded, but that means that 10 and smaller can be solid, is how that works. But if it's 8 or larger, it must be stranded in a raceway. Alright, convert the following measurements to mils. Let me open up Paint. So our measurement we're going for is 0.125 inches. So, if you look, you have, holding my pen wrong, 0.125 inches. To convert to mils, you move the decimal 3 times. So it's 125 mils. And that screen is bright. Okay, so 125 mils. Most of y'all did a good job. Change the following measurement to mils. So 5/8 of an inch. So for this one, you'll want to get out a calculator, because you need to convert it to a decimal form. So you'll do 5 divided by 8. Gives you 0.625. Going back to my screen, that's 0.625. And you move the decimal 3 times. That's 625 mils. Alright, next up is 6 inches. Well, 6 inches, that's pretty easy. For consistency's sake, that is 6 with a decimal. And then you move the decimal 3 times. That's 6,000 mils. The square mil area for a 2-inch wide by 1/4 inch thick copper bus bar is blank square mils. So this is just calculating area. So if you have this whole setup, I have this and a pen. Still can't draw a straight line, but you know, we do what we can. Okay, so it was 1/4 by 2. So a 1/4 inch is 0.25. So this will be 2,000 mils by 1, 2, 3, 250 mils. You're going to do 2,000 times 250, and that should give you 500,000 mils squared, or square mils. That's the wrong button. Alright, next up is going to be, hang on, need to be able to see myself. The circular mill area of a 1-gauge copper-clad aluminum wire. This is going to be in Chapter 9, Table 8. Somebody said they are struggling. Well, the good thing about this being a video is that if you are struggling to keep up, you can, 1, go back and rewatch the video. 2, you can slow down the playback of the video also. If you have an actual question, you are welcome to ask it, and I will address that question as you ask it. And that's part of the live stream experience, is you can ask me a question, I will get to you as I can. Alright. The circular mill area of a 1-gauge copper-clad aluminum wire. So this is in Chapter 9, Table 8. You just flip to that page. 1-gauge wire. The copper-clad aluminum is extra information. It doesn't mean anything. It means something, but not for this question. So 83,690, that will be in your code book, and you'll just have it. Alright. Now, finally, what is the circle mill area of a wire having the following diameter? This is 25 mils equals blank circular mils. So, what you're going to do for that? I'll do it over here. So you have 25 mils. So 25 mils. To get that into circular mils, you will just square that number. So 25 squared, I will use my calculator, is 625. Circular mils. Oop. Need to undo that. All right. Let's see if we can. All right. That was the last question, was 625 circular mils. I'm going to open the floor for questions for a couple minutes before we wrap up. Okay, Red Jack has a question. I don't know who this is. But you can go ahead and ask your question. Oh, that's a good question. Are we going to be doing this the rest of the year? I don't know. I've been seeing people complain that There is like no officials are given like, yeah, this is only going to last for this long, but there's almost no way to tell how long we're going to be doing this. I did rearrange the syllabus, which you can see in the email. Uh, I redid the syllabus so that the really difficult stuff was at the end, uh, so that maybe we are back in class before we get to that stuff. Uh, at the very least, I all that's left is difficult stuff with the first years, so I'm going to be having to teach DC theory with the first years uh, on online like this. I feel like I'm going to be utilizing uh, the Microsoft Paint like this a lot with the first years because I can just throw up a circuit for them uh, and explain it on Microsoft Paint just like I was using a whiteboard. Uh, Not really. Can't really answer that question. Uh, I sure want to be back in the classroom soon. But we'll see how this goes. All right, I'm going to put up the new quiz now. Uh, if the past 2 days I've forgotten to put up the quiz at least once during the day. So if we get to a part of the day where you're all like, this is the same quiz we just did, uh, text me or something because I probably got up and walked away. All right. I haven't ended the stream. Okay, I am. So I have another room that I have open. It's called Code Review, and I will put this name in the chat. Code Review has the previous quiz open. So if you want to go back and redo the last quiz, it will be in Code Review. I'll put that here too. And in the Discord. All right. Good luck on this quiz.